Okay, the problem asks you to use trigonometric substitution to evaluate this indefinite integral. The primary purpose of trigonometric substitution is to clear the integrand of the radical symbol. And so you usually want to create a little right triangle down here, drawing a sketch. That'll help you figure out the trigonometric substitution. When you're going to use trigonometric substitution, you're going to use one of these trigonometric ratios, sine, secant, or tangent. And if this is a minus sign, that means the square root of this term represents the hypotenuse, and the square root of 4 represents one of the legs. And what you want to do is set it up so that one of these trig ratios has 3x as the hypotenuse, and 2 is the leg. The question is, where do you put the leg? Well, if you put, and you want the secant, sine, or tangent of this theta to have this the leg or the hypotenuse with just the x in the numerator. So that leaves secant, because we want the hypotenuse on top, and we want this leg in the denominator. So that tells you that we're doing the reciprocal of cosine, which is secant. So the secant of theta is equal to 3x over 2, and that allows you to deduce a lot of other stuff. If you want to solve for theta, which we might need later, theta is the angle that has a secant of 3x over 2. If we solve for x equals 2/3 secant of theta. If we take the derivative, dx equals 2/3 secant theta tangent theta d theta. And also, this is the primary reason we use trig substitution. For this x, we're going to substitute 2/3 secant theta. So when we square that, we get 4/9 secant squared theta. These 9's cancel out. And we can factor 4 from both terms now under the radical. There it is. And secant squared theta minus 1 can be replaced with tangent squared theta. And what do you know? We can take the square root of both factors and get 2 tangent theta. So that's what we replace this with. There it is, 2 tangent theta. dx we replace with 2/3 secant theta tangent theta d theta. There's dx right there. And x cubed, there's x, 2/3 secant theta, so we cube each factor, 8/27 secant cubed theta. Let's figure out what the numerical coefficients simplify to. 2 times 2/3 is 4/3, divided by 8/27 is the same as multiplying by 27/8. These cancel, and so we've got 9/2 in front. There's 2 factors of tangent squared theta. 1 factor of secant theta cancels out in the denominator. And finally, we use the identity that sine squared over cosine squared is tangent squared. 1 over cosine squared is secant squared. These cancel. And there's the integrand we want to evaluate right there in terms of theta. Now, it turns out there's a couple ways to find the antiderivative of sine squared theta. I won't go through that. Integration by parts, you can use a trig identity. So you don't have to use integration by parts, but this is the antiderivative of sine squared theta right here. I guess you could distribute the 9/2. Finally, I added on the constant of integration. And now we want to go back to x, and here's where the little diagram helps. Of course, theta is inverse secant of 3x over 2, so there's theta, minus 9/4. Now here's where we refer back to the diagram. What is the sine of theta? Well, it's the square root of 9x squared minus 4 over 3x. That's a 3. At times, what's the cosine of theta? 2 over 3x, adjacent over hypotenuse. Of course, you can simplify this a little bit. I can see that these 3's cancel out, with this 9. 2 goes into 4 twice. So it looks like that last term is minus square root of 9x squared minus 4 over 2x squared. And of course, we have this 9/4 inverse secant of 3x over 2 as another term out here, and still the plus c. There you go. Hope that helped. If you have any questions, post a comment.